Okay, here's our video for 3.2 logarithms and their graphs. So very similar to exponential, very, very similar. So we are going to make sure that we take our logarithm in whatever form it's in, so whatever the base is, and we're going to rewrite it in our form by factoring out the b value, basically. So that's the one thing that we're going to kind of focus on right there, is making sure that we have b parentheses x minus c. So we want the coefficient on the x to be 1. A, B, C, D do the exact same thing they've always done. It hasn't changed. I'm going to identify the parent function or the mother, create a table. This looks very similar to the exponentials. Do our transformations, graph and explain. Maybe we'll throw some domain and range and x and y intercepts in there as well, since we're here, may as well. So if we take a look at this, just a reminder up at the top, so the one that I have graphed here is this f of x is equal to log of x. And then what I have here, remember, if there's no base, you have a base of 10. So let's jump right in. So the first thing that I want to do is I want to rewrite this in our form so that my coefficient on my x has been factored off. So if I rewrite this as g of x, this negative sign out in front, I'm going to put a -1 and then a multiplication dot so I can see that that's actually my a value. I'm going to factor my 2 out. And then always do like a quick check. If you multiply this 2 times x minus 2, do you get back what you started with? So it's always worth it. Just kind of slow down for a second and make sure that's correct. And it is. Okay, so let's go through. We need to identify what our parent is here. So let's log base 3 of x. So we're just going to start making our parent points now. Okay, so we'll have the parent, and that's going to be y is equal to log base 3 of x. Come up with those parent points. Okay, so very similar to exponential, whereas with exponential, we did -2 to 2 for the x's. We're going to use the idea that logarithms and exponentials are inverses of each other. So I'm going to swap the x and the y value. So instead of -2 to 2 for the x's, I'm going to do -2 to 2 for the y's. So I'll do -2, -1, 0, 1, 2. But when I come up with these points, I'm not going to do logarithm points. I'm going to do exponential points. So I'm going to rewrite this or treat this as, at the very bottom, like 3, because that's the base of my log, to the power of whatever my y value is. So down here, this would be 3 squared, which is 9. And since I know the positive, I can do the negative. Remember, negative exponent just means to change location in the fraction. I'm going to go down to the 1. 3 to the 1 is 3. So 3 to the -1 is 1/3. And then 3 to the 0 is 1. If you take a look at these points, if you were to invert them, so it would be -2, 1/9, -1, 1/3, 0, 1, 1, 3, 2, 9. Those would be the parent points if it was y is equal to 3 to the x power, which is basically what I did. And then I was like, okay, well, logarithms are inverses, so let me just flip all of the points. So that's really all I did there. Okay, so let's take a look at the x's first. Remember, you follow order of operations. But with x's, it's the opposite of what it looks like. So the first thing that's going to happen with the x's, it looks like it's timesing by 2. That's not true. It's not timesing by 2, it's dividing by 2. Or you could say times by 1/2. Those are technically the same thing. Then it looks like it's -2. That's not what we want to do, though. We want to add 2. So it's the opposite of what we think is happening. Okay, so I'm going to do my 1/2, my x value, and then plus 2. 1/2, my x value, plus 2. All the way down. Okay, I'll go over here. What do I call this thing? G of x. Okay, so if I do a half times 1/9, that's 1/18 plus 2 is 2 and 1/18. That's 2 and 1/6. That's 2 and a half. That's 1 and a half plus 2. That's 3 and a half. That's 4 and a half plus 2. That's 6 and a half. Okay, now let's take a look at our y's. And remember, with the y's, it's exactly what it looks like. So it looks like I'm timesing by -1. So I'm going to take my y and I'm going to times it by -1. And then I'm going to add 1 to it. All right, so let's go ahead and fill this in. Okay, so that's going to give me 2 plus 1, that's 3. 1 plus 1 is 2. 0 plus 1 is 1. -1 plus 1 is 0, and that's -1. Get rid of that errant mark. Let's put some commas between these now. Okay, before I start graphing this, I want to identify where my asymptote is. Well, if it's a logarithm, the asymptote is always going to come from the value that makes the inside of the logarithm 0. So I'm going to look at that 2x minus 4. So whatever I plug in for x, that turns this into 0. Well, you can even look at this one down here. So it's the exact same thing. It's just that now we have the factored version of it. So I am going to say that my vertical asymptote, logarithms always have vertical asymptotes, is going to be at x equals 2. So I want to fit a couple of these points on here. Make sure that your coordinate plane is large enough to hold the stuff that you need, the points that you need to plot. So let's go ahead and figure out where you want to put yours, and I'm going to go ahead and put mine on the graph as well, my xy axis. Okay, so all my increments are 1. I'm going to put my vertical asymptote on here at x equals 2. And then let's see, 2 and 1, 6. Well, let's do 2.5, comma 1 first. 1, 2.5, comma 1. And then 3.5, comma 0. And then 6.5, comma -1. I think it might be too tight of a fit for me to try to put the other ones on there without hitting the vertical asymptote. So I'm just going to go ahead and give it a sketch. Remember, it's a nice smooth curve. It never really goes completely flat. It looks like it, but it doesn't. Okay, so there's my graph. So I've got my vertical asymptote identified. Let's see. We could do domain and range. That's a reasonable ask. Domain, well, it looks like it gets really close to 2 and then takes off to positive infinity. Range, all real numbers. It's kind of nice with logarithms. It's like exponentials. Their domain was all real numbers. Logarithms, their range is all real numbers. Okay. Let's see. There is no y-intercept. So there's no point in me going through and doing work on it. There's a vertical asymptote in the way, so I'm not going to go through and do any work on this. The x-intercept is in the table. That's nice. So that was my 3.5, comma 0. Okay, now we just need to list out our transformations. And we're just going to do it the same way that we did with the exponentials. I'm just going to go ahead and take a look at the pieces of what's happening to this thing. Okay, so let's take a look at our x's first. Looks like with our x's, we divided it by 2 first. So we took the distance between the x values and we shrunk it. So if the distance was like 10, if we divided it by 2, it's now 5. So that is, x is in the horizontal direction. So this is a horizontal compression by 2. So horizontal compression. by, you can even say a half. Or it's horizontally, yeah, let's do a half. Then we've got a plus 2. That tells us that we're going to go right 2. Okay, let's take a look at the y's now. So we times it by -1. So that means we vertically reflected this thing. And then we plused 1, which means we took all the y values and we moved them up. So that's up 1. Okay, there's our first one. Now here's our second one, very similar to the first one. This is an excellent opportunity to see if you can set up the table. Can you set this up in our form, so the correct form, to be able to transform the points? So now would be a good time to pause the video, see if you can set up the table, at least the parent points, and then pause and see if you can come up with the transformations as well. Okay, so I'm going to put that multiplication dot there so I can see my A. I'm going to factor out the 1/3. And I'm using brackets just because the parenthesis business can look a little confusing after a bit. Okay, now do a quick check on this. Make sure that if you distribute that 1/3 times x minus 3, you actually get 1/3 x minus 1. If you don't, then make sure that you fix it. You want to make sure this is correct before moving on. Okay, the parent of this thing is log base 2 of x. So I'll set up my table. And then I'm going to set it up just like I would if it was exponential, but I'm going to reverse the points. So I've got -2, -1, 0, 1, 2. Not as my x's now, they're my y's. And then I'm going to do 2 to these powers. So that's a 4, which means that's a 1/4. That's a 2, so that's a half. That's a 1. Okay, let's take a look at our transformations now. So the first thing that's going to happen with my x's is that 1/3. So it's timesing by 1/3, so I would want to divide by 1/3. Dividing by 1/3 is the same thing as timesing by 3. Then I would minus 3, but I want to do the opposite, so it's going to be plus 3. Okay, so plug in my x's. And just because you're finding these points doesn't mean you're going to plot all of them. It kind of depends on how large they are, if they're a reasonable plot or not. Okay, we'll do the math. 3 times a fourth is 3/4, plus 3 is 3 3/4. That's 1.5, so that's 4.5. That's 3 plus 3 is 6. That's 6 plus 3 is 9. 12 plus 3 is 15. So yeah, I might not plot the 15 because I don't know if I can actually get it to fit on my graph over there. Okay, let's take a look at the y's. So I'm going to times by a half first. So I'll take my y value and I'll times it by a half. And then I'm going to subtract 2. I'm just filling in my table. Okay. That's going to give me -1 minus 2 is -3. That's -1/2 minus 2. That's -2.5. 0 minus 2 is -2. That's going to give me -1.5, and that's going to give me -1. Okay, so those are my points. Before I start graphing this, I need to look for my vertical asymptote. So remember, it is the thing that makes the inside of the logarithm 0. As it's really the boundary between like a logarithm existing and not existing. Okay? So, but I think I'm going to look at the more factored version of it down there. So I'm going to say that my vertical asymptote is at x equals 3. Okay, so let's take a look at this thing. Make your setup where your x and your y axes are going to go on this graph. I don't know if I'm going to be able to get the 15, -1 to fit. Maybe? I don't know. I'm probably going to put my y-axis super far to the left and then go from there. Okay, so I've got my axes on. Let's go ahead and put the vertical asymptote on here. X equals 3. Let's see. 3 3/4 -3, that's kind of close. Let's go with the 4.5 -2.5. So 3, 4.5, -2.5. Let's look right there. Okay, then 6, 3, 4, 5, 6, -2. And then 9, 6, 7, 8, 9, -1.5. And then, I don't know if this will fit, 9, 10, 11, 12, 13, 14, 15. Okay, I could get it to fit. -1. Oh, okay, I plotted this one wrong. I did not go down far enough. So -9, so 6, 7, 8, 9, 1.5. There we go. There we go. Okay. All right, let's see if we can get a decent sketch. Remember, it doesn't go flat. It kind of looks like it does, but it does not. It keeps growing up. I'm actually going to fix this down here because it kind of looked like I curled back on itself. I'm going to make sure that this is still a function. Here we go. Okay. Let's see. Reasonable asks. Domain and range for sure. So domain looks like this thing is starting at 3 and then takes off to positive infinity. Range, all real numbers. Let's see what else. Y-intercept does not exist. It's not going to hit. X-intercept, it is going to hit. Looks like I need to find that though. Okay, so X-intercept, let's do that work over here. So an X-intercept means you plug in 0 for Y. So it's going to be 0 is equal to 1/2 log base 2. I'm going to use the non-factored version, so the 1/3 x minus 1. And then minus 2. Okay, let's solve here. So I'm going to add the 2 to the other side. I'm going to divide by half or times. That's going to give me a 4. Okay, 2 to the 4th is going to give me 16. Add the 1. And then times by 3. Holy, this thing's at 51. Okay, so my x-intercept is at 51, 0. Okay, what else? Transformations for sure. Okay, let's take a look. What happened with the x's? I'm looking at my table. Okay, so I times my x's by 3, so I increased the distance between my x's. So that's a horizontal stretch by 3. And then we added 3 to the x's, so we went right 3. Okay, let's take a look at the y's now. So what happened with the y's was that I times it by a half. Okay, so that means that I took the distance between the y's, that's a vertical distance, and I shrunk it. So this is going to be a vertical compression by a half. Okay, and then, so we minus 2 after that, and that minus 2 is going to be down 2. Okay, last question. You're going to want to have a calculator in front of you for this one. So pause the video, take a minute, read this to yourself, see what we're trying to do, and then when you're ready and you've kind of digested it a little bit, unpause the video and come back and we'll go through it. Okay, so what we have here is we have a formula that is scores for the class for human memory model. And there we go. It's from 0 to 12. That's it. Time is in months. So it's basically for the first year. What's the average score in the original exam? So when they started, you're even told to put in t equals 0. So we're just going to do f of 0 is equal to 80 minus log base 10 of 0 plus 1. Okay, now we don't need a calculator for this one. It's going to be 80 minus log base 10 of 1. Well, log of 1 is 0. So it looks like the score to start is going to be 80. What's the average? What average score? Average score after 4 months. Okay, now we're going to plug in 4. Now, if log base 10 of 5 had any specific meaning to us, I would say, okay, evaluate it from there, but we don't. So in your calculator, so even Desmos calculator, the logarithm button option is programmed with a base of 10. So all we have to do is type in 80 minus log of 5. Don't even need to specify the base. It's programmed with base 10. So it looks like this is going to be approximately 79.30103. So if I pulled all of the decimals off there, remember you can also round or truncate to 3 decimal places. Okay, if the average score was 78.9, okay, so we're not talking about time now. We know what the score is. We're trying to find months. So how many months passed? So this means find x. So we're going to take our formula and we're going to do 78.9 equals. And then use our formula, which was 80 minus log base 10 of x plus 1, or t plus 1. Let's say find t. Okay. All right, this isn't that bad. This is kind of similar to what we've been doing to find like x and y intercepts previously. So I'm going to subtract the 80 to the other side. You're still using a calculator. 78.9 minus 80 is negative 1.1. Negative log base 10 of t plus 1. Get rid of that negative sign so we can just cancel those out. So 1.1 is equal to log base 10 of t plus 1. Let's rewrite this. So it's 10 to the power of 1.1 is equal to t plus 1. And then we're going to subtract the 1. Once we get to this point, let's put this in the calculator now. So I'm going to do 10 to the power of 1.1. Make sure that you bring your cursor down from the exponent after you do the 1.1, and then do minus 1. So it looks like t is approximately 11.58925412. Okay, turn that into 11.589 months. So really the thing here is just making sure that you plug the value into the correct location in your function. And I think that figures it out for us. I hope this helped.